Hey guys, this is Carrie Rhinehart with 5-Minute Math. Today I'm going to look at systems of equations by graphing. If you're following along in the book, it's from Algebra 1, Unit 4, Lesson 1. Okay, so we're looking at systems, and a system is just a fancy word for finding the intersection of two or more functions. And for now, we're just looking at two lines. Where do two lines intersect? And there's three things that can happen if you're graphing two lines. So the normal thing that could happen is that two lines intersect, okay, and they would cross in just one point. This situation is called consistent. And your answer is the ordered pair where they cross. We got an ordered pair, wherever it is that they cross. Another thing that could happen is that the two lines could be parallel. And remember, when two lines have the same slope, that means they're parallel. They will never intersect. We call this inconsistent. There's no solution here because they will never cross. And then the last thing that could happen, which is rare, but it is possible, is that the two lines are the same line. So let's say that's the first line, and then the other one is the same exact one. Okay. So if you notice, they share all the same points. Okay. We call this a dependent system because every single point is a crossing point because they're the same line. So this would be infinite solutions. Okay, the main one is the consistent one where they cross. You're going to get an ordered pair. But there are these other two situations. If they're parallel, there's no solution, and we call that inconsistent. Or if they're the same line, we call that dependent, and there's infinite solutions. So let's look at an example of how we would solve this graphically. Okay, there are several ways to solve these systems, but the first one and the one I'm looking at in this video is on how to do it graphically. So let's say we're given y equals 2x minus 1, and we're also given the equation y equals negative 3x plus 4. If you have colored pencils, those come in handy for systems. So the first thing I'm going to do is graph this line. Okay. It's already in slope-intercept form, so that makes it easier for me. The y-intercept is at negative 1, so it's crossing right here. And the slope is 2, so that's rise 2, run 1. Okay. Rise 2, run 1. And with systems, I try to get as many points on this line as I possibly can, because we want it to be as precise as possible. We want to know exactly where these two lines cross. Okay, so I'm going to go ahead and draw that line. Now I'm going to do the next one, and I'm going to do the next one in red, so I know which is which. Again, this one is also in slope-intercept form, which is nice. My y-intercept is right here. It's 4, so it's crossing the y-axis at positive 4. And my slope is negative 3, which again you can put over 1. So from 4, I'm going to go down 1, 2, 3, and then run 1. And you'll see right there they cross, but I'm going to keep going down 1, 2, 3, run 1. Keep going down 3, run 1. I'm going to draw my line here. Okay. And what we're trying to do here is solve the system. And remember, when you're solving a system, you want to know where these two cross. Okay. Well, they cross here at the ordered pair 1, 1. And since they do cross, this is a consistent system. And to check this, you can plug in the ordered pair 1, 1 to each of these equations. So if I plugged it into the first one, I plug 1 in for y and 1 in for x. So I get y equals 2 times 1 minus 1. Just keep a 1 over here. 2 times 1 is 2. Keep this 1. 2 minus 1 is 1. And that is a true statement. 1 equals 1. And you'd also want to plug it into the other one. You're plugging 1 in for y and 1 in for x. So in that case, I get 1 equals negative 3 times 1 plus 4. Keep the 1 on this side. Negative 3 times 1 is negative 3 plus that 4. Keep the 1 here. Negative 3 plus 4 is 1. 1 equals 1. That is true as well. So we know that this is the correct solution. All right, guys, I hope you have a great day.